Lesson 8.2 is solving exponential equations. So we're going to be working with equations such as 2 raised to the x equals 2 raised to the 3x and solving this for x. So copy down your title and your essential question. And then you have these notes to copy down as well. And there's just a little bit more on the next page. And then here's your last page of notes to copy down. Okay, let's look at some problems. So we've got the equation 3 raised to x equals 9 raised to the 4th. And actually, I think I had it in another problem. Hold up just a sec. Well, let me just rewrite this problem. We're going to do that problem in just a second, but I want to do an easier one first. What if we had 3 raised to 2x plus 5? So now both of the bases are the same. And so if both of the bases are the same, that means that the exponents should equal one another. Just like we used back here. If 3 to the x raised to the x equals 3 to the 5th, then x has to equal 5. They have to be the same. So here we're going to use that and say x has to equal 2x plus 5. And then we just have a linear equation. Drop down your line and solve it. We end up with negative 1x, because remember that's a 1 there, equals 5. Divide both sides by negative 1, and x equals negative 5. So let's go back and look at this problem then. Now the bases are not the same, but we could get the bases to be the same. So in this case, I could rewrite 9 and say that it's 3 squared. So 3 raised to the x is 3 squared raised to the 4th, because 9 is 3 squared. Okay, and then we can multiply exponents. So 3 raised to the x equals 3 raised to the 8th, so x has to equal 8. And how about this one? Again, the bases are different, so we need to get the bases the same first. Now, in this lesson, you will always be able to get the bases the same. If you cannot, you'd have to use logarithms, but we're not going to cover that this year. That's something you'll cover next year. You should always be able to get the bases the same. So we can write 4 as 2 squared. That's 2 squared raised to 2x minus 1. So what we do in this case is we're going to distribute that 2 through. So 2 raised to 5x equals 2 raised to 4x minus 2. Now the bases are the same. We can write the exponents equal to one another. And we'll drop down our line. And we have x equals negative 2. That's our answer there. Okay, and then we're going to work with exponents a little bit more here, but in a real-world problem. Okay, so we have in 2000 the population of Phoenix was 1.3 million approximately. In 2007 it was about 1.5 million. Write an exponential function that can be used to model this. So an exponential function is y equals c1 plus r raised to t. Now the book also talks about it as a and then b raised to x. But I'm going to go with this equation because that's how we've used it in the past, and it's just a good equation for you to remember. So what we do here is we think about c as our initial amount. That's what our initial amount was. So I'm going to put that in 1321045. 1 plus, we don't know what our rate is, and we're going to have to find that, so I'm going to leave that as r. But we can use 2007 and the 1.5 million number to help us figure out what that's going to be. 1.5 million is going to be in for y. And 2007, which is going to be 7 years after it, goes up there. Okay, how are you going to solve this? Well, the first thing that you have to do is, when we're trying to get r by itself, is to get rid of that 1.3 million. And what's happening between the 1.3 million and the parentheses? It's being multiplied. So we undo that by dividing both sides by 1321045. Now take out your calculators and type that in. And you might need to hit pause here so that you can do that. But you're going to get approximately 1.145 0.29. Now do not clear out your calculator screen. I want you to keep all the numbers on your calculator because we don't want to cut our decimals too short too soon. Now, how do we get rid of the 7th power? We would do so by taking the 7th root. But we can't, or the way that we calculate the 7th root is raising everything to the 1/7. Oh, that's not times, it's raised to the 1/7. So now what I want you to do on your calculator screen is raise your last answer. So don't clear your screen, just press the raise to, and then type in 1/7. Make sure you remember to use parentheses if you need to. And we should come up with 1.0196 if we round it. 1 plus our rate. Okay, so we could, if we had to find what the rate was exactly, we could minus 1, but we need to write an equation. So we can plug this in for this right here, because it equals 1 plus r. So let's rewrite our equation then. Y equals our initial amount, parentheses, our rate, raised to t. That's the formula, that's our answer. So now let's use that to predict what it's going to be in 2013. So let's just go back to this page, and I'll just put 2013 here. So what you're going to do is just go to your y equals on your calculator and type in our equation. And you can go ahead and hit pause if you need. And instead of raising it to t, you want to raise it to x. And then let's look at your table. Now if your calculator is in the single digits, oh, that's where we actually want it to be. We're not looking at 2013 on our table. We're looking for 13 years after 2000. So you want to find on your table 13. And so at 13, it reads off 1.7 E6. Now that E means that you need to move the decimal 6 places over. But if you press your cursor over one spot and look at the bottom of the screen, it tells you the exact number, 1700220. And it's people, so we probably should round that up to a whole person right there. So in 2013, we're predicting that there's going to be 1.7 million people. Okay, and then the last example we're going to do is how to compound interest. So what it means to compound interest is that, let's say that you have some money in the bank account, and the bank is going to give you interest after each month. So that means after January, they're going to calculate how much interest you've earned and put it into your account. So then when it comes to February, you get interest on the money you put in there, plus that little bit of interest that you earned in January. So you're going to actually get more interest in February than you did in January because you're getting interest on your interest. So let's work through this problem. They're compounding quarterly, and we've got $4,000, 5.4% for 8 years. So here's our formula to use. Let's plug it in. Our principal amount was how much we put in there, $4,000. 1 plus our rate. Now remember, you have to take the rate divided by 100. So we use it as 0.054 divided by n. N stands for how many times in a year do you get interest. Since it's quarterly, that means it's 4 times a year. So then we put 4 times how many years? 8. Now in this case, you can just go and type this into your calculator, but what I would suggest doing is rather than typing in 4 times 8, just type in 32, raised to 32. Because otherwise you have to do the whole parentheses raised to another parentheses 4 times 8. This way, after this parenthesis, you can just do raised to 32. That's a little bit quicker. So if we go ahead and type that in, you might want to hit pause so you have time to do that. You should find out that you have $6,143.56. That is how much money you have in your bank account. After 8 years, you have gained $2,100 approximately. Okay, so let me just show you one more problem that's going to be kind of like, let's see, this problem here. But in your homework, they're only giving you points. rather than giving you a word problem. So let's do one more of those. Okay, so let's start with 0, 7, and 5, 23.1. So we're going to use this equation. But in this case, our starting value, since this is 0, our starting value is 7. Then this goes in for our x, and this one goes in for our y. So we'll write 23.1 equals our starting value, 1 plus our rate, raised to the 5th. Okay, so you take 23.1, divide that by 7, you get 3.3. So then you undo raising it to the 5th by raising it to the 1/5. And remember, oh, I typed that in wrong. Don't want to cut off decimals too short. And so we end up with 1.270 is our 1 plus rate. So when you write the equation, it's y equals our initial amount, 7. 1.2070 goes in for 1 plus r, raised to the t. That's going to be our answer there. Okay, that's the end of lesson 8.2.